All right. Would anybody be interested in having Monday off? So, oops, that's not what we want. Anyone? I'm not hearing. Okay, because I'm thinking that that we actually there's a lot of classes that are being um, canceled next week because of the holidays and just the general level of stress that's out there. So I talked it over with the GSIs, and we are thinking about canceling class to give you the full week break next week. So unless that's a terrible disappointment, hoping that it's not. Yeah,
Professor,
what's
people are just wondering like what's the catch beyond like just giving us like the extra day off?
no
Like,
catch. I'm not going to. There's not going to be a negative implication for you. Basically, what I want you to do though is it gives you time to catch up on the lectures and come up to speed on everything that you need for the homeworks. So I'm going to try and get through everything here on normal forms right now, and then you'll have time to work on the homework and just catch up in general next week. Okay? There's not that I'm gonna put any extra demands on you. Okay? So there's no catch really. All right?
Sounds
Okay.
great to me.
Okay. That's what I was hoping to hear. All right. So let's go on. Let's jump in here. I sent out some notes. You saw that our Chris really gallantly went in and went through and tailored every single lecture that was recorded and cleaned it up and organized it because it was very, very hard to find things. I completely agree with that. So now it's all cleaned up. You can find each of the lectures in order. Within the lecture, you can go in, there's a playlist, and you can find the individual topics are well organized. Labs are separate. And as he said, he also put your presentations for the projects into their own categories. So this took several hours, and he was very diligent in doing so. So again, I appreciate Chris for doing that, and I think we'll all benefit as a result. Okay, so let's go back to where we were. We talked about normalization. We were able to put this relation into a second normal form, and what we were doing was removing making sure that the non-prime attributes here are fully, these non-prime attributes, as circled in green, are fully functionally dependent on the candidate key in each of the relations. Okay, so now we're ready to go to the next step, which is third normal form. And third normal form is going to disallow transitive dependencies. And this is case even if there's only a single primary key. And let's define what we mean. Well, first of all, a relation can be here. Actually, let me turn it this way. I think that worked out better last time. Yes, good. Right here, a relation is in third normal form if it is in second normal form and there's no non-prime attributes are transitively dependent on the primary key. Okay, and if you recall what transitive dependency meant, it's that you have this case here where you have the, let's say, a key here that determines some attribute B, and then B determines Y. So this is the non-prime attribute that serves to create the transitivity. So you want to eliminate these B attributes. So you want to get them out of there so that you don't have this transitivity. All right, so Kent basically says that he summarizes this very elegantly, that the condition is that, well, I actually like this. He says it's not in third normal form if there exists any non-prime pair such that A determines B. Okay, so this is really intuitive and easy to understand to me. And let's look at how that might play out. So let's look at this one here. We have in the fourth relation, we have course professor. Now, does anyone spot what could be the non-prime pair there that would determine each other. So just look at the last two. Faculty ID determines faculty last name, right? Now, also, let's just look at this first. And actually, why do we care about this? This is actually helpful. Let's look at these issues. Now, we're looking at this relation right here. And what are the problems with it? Well, that we have information, that we have before we've started a course, we might be hiring a new faculty member who's not teaching yet, as we mentioned, and there'd be no way to store the faculty last name. Okay. Now also, you have to repeat this information, so there's a lot of redundancy. For every time you introduce a new course, you have to rewrite the faculty's last name. It's a lot of opportunity for making mistakes and inconsistencies in your data. And let's say a faculty member, they changed their last name, maybe getting married or something, then you have to go through and change all the records. It's not just in one place. You have to change it for every single course that that person has ever taught. Okay, so what do? Well, this is because we have this transitive dependency here, right? We have this, and we have this. So this is not in third normal form, and we can normalize it. And let me pull that up quick. Okay. My notes. Okay. Okay, so what we're going to do is we're going to say 4A here is professor name, and we'll put faculty ID. Faculty last name, like that. Okay. And then we'll have 4B be C prof ID with CID semester faculty ID with the 4A here, right? And this refers to 3. All right, now from both of these are in third normal form. There's no transitive dependencies. In particular, it's very easy to see that by inspection. There's only one non-prime attribute, so there can't be a pair of non-prime attributes. Does everybody see what we did there? And why that is beneficial. So in other words, your intuition, because of the way you've learned how to develop relations from the ER diagram methodology, is that this should come out naturally for you. But you might encounter, in particular cases, in your own designs for your client, or especially in the future when you go out into the world and you are looking at someone else's database that they designed. And you might see things like what we see up above, where it's not normalized. And now you have a language, you have a way of coming in and looking at a relation and saying, wait a second, this is not in third normal form. So let's normalize it. And people will really appreciate it, because you have a way of going in and basically improving their database designs, okay? And improving your own. Okay, so that's third normal form. Let's, and by the way, if you ever wanted to get back to that earlier form of 4 that we had above, all you have to do is join it. So if you do a join of these two relations, right, notice you would immediately get back to where you were. You'd have a relation that has all of them. So you're not losing anything. You're not really getting, it's not like you're giving anything up. And maybe it's like the question at the beginning of class, what's the catch? There's no catch, really. It's just that you're organizing things in a better way. And this way you avoid the redundancy. You put the faculty last name only appears in one place, and you avoid a lot of the inconsistencies that could creep in a database. Okay. Now, let me also point out that there's another definition here that is that says the following. It says that R is in third normal form if, for all functional dependencies, either the left-hand side is a super key, okay, or the right-hand side is a prime attribute. Okay, Y is a prime attribute. Okay. So that is a strong condition. Now, it's not obvious that that's the same thing as what we described earlier, that under that there cannot be a non-prime pair, but there is a way to prove that. And this is a proof that I gave you in the notes. And what I want to do is let you look at that over the break I'm going to give you for the full next week and a half. Actually, it's not a break for the week and a half, by the way. I want to stress that we are going to have lab on Friday, and it's actually an important lab because it relates to the projects. So please don't skip out on that as well. This proof is rather long, and I'm not going to hold you to knowing this for the final. Basically, I want to just give it to you for information, but if you are unsure about whether or not these two definitions are equivalent, there is a proof right here for you to study. Okay, but I will assure you that it is true that these two are equivalent, and that's really helpful because that leads us to the last form of normalization we're going to look at, which is Boyce-Codd normal form. And you probably recognize Ted Codd from that name. Yes, Jason.
Before we move on to like this next topic, what is wrong with having transitive dependencies in like your database? Like, why would we want to normalize that?
Well, just as in that example we went through here, let me scroll back up to it. It's right here. So here you have transitive dependencies, right? In this case, and you see these problems that you're seeing, right? That you have information being stored that you essentially you want to put information that essentially here, but it's being stored in a way that is very suboptimal. Do you see why? Because if I have a faculty member, it's basically attached onto extraneous information, the faculty name. So faculty name really, I don't really want that to be glued in here into this relation. I want to break it out, separate it. Does that make sense? So that's, but saying why is fairly nuanced, and it took a fair amount of time for researchers to come up with this formalism, and that's what we're spending time on, right? So I'm giving you an analytic way of looking at this relation and noticing something about its properties that then you can say, okay, I'm going to put this into this specific form, third normal form, and I'm going to clean it up. Okay, and it's going to help us avoid these problems that you see here, all these problems that crop up in practice. Okay.
Okay. Thank you.
Sure.